Thank you all for your patience. Hope you got 5 minutes to just relax. Okay, so thanks for coming to our session on the operational analytics with zero-ETL and DBT Cloud. My name is Neeraja Rentachintala. I'm a director of product management on AWS Analytics, leading Redshift as well as Glue Data Catalog and Lake Formation. And the co-speaker.
Hey everyone, I'm Neela Kulkarni. I'm a solution architect at AWS. I've been with the AWS for last 2 years now.
All right, so in this brief talk, we wanted to cover a few things. One, briefly talk about the challenges and opportunities with operational analytics, and share a little bit on the zero-ETL vision of AWS on how we are looking to simplify operational analytics. And then Neela will cover how the zero-ETL and DBT Cloud together can enable and simplify operational analytics in your environments. She's going to walk through a use case, reference architecture, and then a demo. So with this, let's get started. So in our customer base, what we see that as data starts to become kind of an enterprise, an asset, strategic asset to make competitive advantage, many customers are looking to do operational analytics. So this helps them to understand their core business drivers, improve sales, reduce costs, and optimize the businesses as a whole. There are several use cases for operational analytics. So there are more horizontal use cases like fraud detection, churn prevention, and personalization, like looking at what the user is interested in and really providing best experience for them based on their own preferences. And then there are vertical use cases like gaming, leader dashboards, inventory optimization. So most of you are familiar with some of these common patterns, but the key to accomplish all these things is getting access to the data quickly as soon as it is generated, and being able to get insights from it, and being able to act on that data. So while this is super critical that you have operational analytics for some of the key use cases that we just talked about, many customers find it very hard to implement these near real-time operational analytics use cases. And the primary reasons are basically they are setting up manual kind of pipelines between the databases, which are transactional operational databases, into their analytics stores. And at scale, as you have more systems to populate, more systems from which you want to retrieve the data, this can become pretty expensive and cumbersome. And also, like taking an example, if something changes on the source database schema, just reconstructing that on the analytics side itself can be pretty hard and requires a lot of manual work. And the other part is if something happens to these pipelines, they could be fragile, something breaks, then on the receiving end, we have incomplete views, inconsistent views, and stale views that the business users would be getting. So on the AWS side, I'll talk about, for AWS, our main goal is to offer purpose-built databases, both on the operational side as well as on the analytics side. Many of you might be familiar with Aurora, which is a relational transactional database service. It offers the speed and availability of a commercial database, combine it with the simplicity and the cost effectiveness of an open source database. So Aurora offers MySQL and PostgreSQL compatibility, so you can bring your own applications, and also the ecosystem, the tool set that you have around the MySQL and PostgreSQL. It's a fully managed database. So Aurora is used by hundreds of thousands of customers, right? So it's a pretty popular database. On the analytics side, we have Redshift. How many of you are familiar with Redshift? Okay. So this is an enterprise-grade cloud data warehouse, offers up to 6x better price performance compared to the alternative systems. And over the past 3-4 years, we have added a lot of capabilities to Redshift with capabilities like data sharing, serverless. So the goal is really to be able to get to all the data, bring it into Redshift, and do different types of analytics on top of it, including business intelligence, Spark applications, machine learning. There are a number of capabilities that enable this. I expected that there are going to be Redshift users in the audience. So some of the recent innovations on Redshift side, just to highlight a couple of them, On the serverless side, for example, we have expanded our RPU range. RPU is a Redshift processing unit, the compute range, so that you can onboard more types of workloads onto serverless. Serverless now also has AI-driven scaling and optimizations, which means that it is much more aware of the workload changes, like data changes, the number of users changes, and it is able to much more intelligently scale the compute based on the workload requirements. A lot of other capabilities, multi-warehouse writes, with which you can use many computes to write to the same database. This is a capability that we launched at last year reInvent. We have, on the consumption side, we have introduced LLM support on Redshift ML. Spark support is much more mature now. We have streaming ingestion, which is a very popular feature. On the security, we have things like dynamic data masking, row-level security, column-level security, as well as multi-AZ. So there are a lot of blocks and feature on these capabilities. Feel free to ping me after this talk. So now customers have these purpose-built databases, operational and analytics. So how are they putting together AWS customers? This is just one example of how they connect the dots between Aurora and Redshift. One of the key problems for near real-time analytics is you want to bring the data from operational system to analytics system without impacting the production application on the operational database. So to accomplish that, customers prior to zero-ETL, they would offload data from Aurora to S3 using a service like database migration service, and then do some processing on the data, because in operational databases, data is in denormalized fashion, so you want to massage the data to be analytics-friendly models. And then you bring the data into S3 and then ingest into Redshift. As we talked earlier, this kind of an architecture is complex to start with. And the second part is, most importantly, it doesn't get you the data in near real time with this kind of a pipeline. So this is really kind of an example situation where we at AWS in 2022 reInvent, which is a couple of years now, has pioneered this idea of zero-ETL, where can we provide a secure and easy way to bring data from operational databases into analytics stores while ensuring that there is isolation and performance. So with the zero-ETL integration, it is a much simpler picture. As you can see, I have Aurora. All you do is you set up a zero-ETL integration. We'll see that in the demo. And then within seconds, the data shows up in Redshift. So zero-ETL is really a continuous data replication system. It's a change data capture based replication. And once the data is in Redshift, you can use all the power of Redshift to do analytics on top of it. From a benefits point of view, first of all, it's easy because you are not managing this whole pipelines to bring the data from operational databases to analytics. It's low latency, so we are talking about seconds. Within seconds of data being written to Aurora, it shows up in Redshift for analytics. And it's also unified insights. What we mean by that is you might have hundreds of Aurora databases, thousands of Aurora databases. All that data can be brought into Redshift for analytics. So you are able to do many to one, from many databases into one operational one analytics data warehouse. A key point to mention on the zero-ETL is the architecture is designed for performance, isolation, and resiliency. So ease of use is clear, right? Which is you don't have to set up a pipeline. But the important point is it's also designed for isolation. So in zero-ETL, the continuous data replication is happening at storage level. So the data is being replicated from Aurora storage to the Redshift managed storage directly. So from a replication point of view, we are not going and touching the Aurora head node, which would impact the production applications that could be running on Aurora system. So this is a storage level replication. As I mentioned, this is a CDC base, so it's a change data capture, which means that as and when new data gets added on Aurora, including schema changes, they get replicated in near real time. It is also resilient, so something happens on Aurora side, Redshift side, there is a temporary downtime. Many things can happen. In these situations, the system will understand where the replication stopped. the checkpoint, go back, bring, resync, and make sure everything is transactionally consistent. So this feature is launched as a preview, as I mentioned, at 2022 reInvent. Last year in October, we have launched the general availability of Aurora, specifically starting with Aurora MySQL. So till date, we have about 2 petabytes of data that has been transferred from Aurora MySQL to Redshift. And across the fleet, the latency that we see with respect to how much time it takes to bring data into Redshift, it's literally less than 10 seconds, 8 seconds. So we have seen customer examples where they were able to do 1 million transactions and bring it into Redshift in 15 seconds. And as you can see in this customer codes, it's two things that really are important to them. One is bring the data in near real time, and number two, do it without having to kind of worry about the complexity of the data pipelines. So we talked about Aurora MySQL because that's kind of what we started with. That's generally available. There are additional zero-ETLs that are available. We just launched RDS MySQL. It's generally available. We also have previews for PostgreSQL and DynamoDB that will be launched as generally available very soon. So with that intro, I'll hand over to Neela to walk us through the demo.
Hello, can you hear me? Okay. So who is going to answer that question? What is DBT? Data build tool. Okay. How does it integrate with Redshift? Perfect. So the way it works, sorry. So DBT is a framework. It sits on the top of Redshift. And Neeraja touched upon ETL pipeline, right? So if you think about the ETL pipeline, you have your raw data on the left. That data is getting loaded into Redshift. And then we are running the DBT on the data that is loaded on Redshift, which you can develop, test, or create models. And then it is going to create a clean, consistent, and trusted data set for you, which you can use it into your BI tools, ML models, or any operational analytics that you have. It's not working? Okay. So what does it showcase now? Is it a ETL or is it ELT? ELT. So DBT is actually defining T, but this integration with Amazon Redshift is giving that ELT mechanism. This is modern ELT. Now, how DBT and AWS are better together? With AWS, we are giving you the capacity, like storage capacity, compute capacity, where you're able to load excessive data, like petabytes of data. And you're using DBT on that data, where you're able to do the transformation easily and with higher performance. There's no performance degradation when you're using DBT on a Redshift. Redshift also has a lot of security controls, where you're able to do row-level security control, column-level security control, role-level access controls. All those controls are also propagated into DBT. So you are able to, data security is maintained. You're able to do the governance, and scalability is obviously there. So the demo that I have today, use case and reference architecture. So we have any company. Any company has a website for ticketing. We are not Jaffle Shop, but we are any company. What this website does it allows you to buy and sell the tickets online for the sports events or concerts. And what is going to happen is when the data comes on Redshift, your analysts are going to use that data to generate what shows are best sellers, who is selling those tickets, so that they can provide the incentives to those sellers. All that data will be utilized here. And we are going to use zero-ETL for getting all that data from Aurora database into Redshift. So in Aurora database, you have multiple tables, multiple databases. And I'm going to showcase how easy it is for you to do that zero-ETL integration. Okay, before that, I may need to do some setup here because we lost the connectivity, so give me just a minute. Are you able to hear me? The setup that I'm going to show is on AWS console. So I have to log on to AWS console. Just give me a minute. Okay. It's taking time. So as I said, we already have data into RDS. So the setup is, I have created RDS data store here. So you can see the DB instances. These DB instances are created. It's a MySQL database. And I also have a Redshift database set up. In the Redshift, we are using serverless. So this setup is already available. Now, let's create a zero-ETL integration. On the RDS menu, you will see zero-ETL integration here. And the integration creation is simple. All you need is a source database, what is your target database, and if there are some prerequisites that are needed for your source database, but again, when you go into the process, it really helps you fix those problems or issues that will be there. So for example, let's say I'm getting this zero-ETL integration here. Next, I will be able to browse by data source. Oh, sorry. Click on radio button. Click choose. And one of the requirement for your source database is to set up certain parameters. Those parameters are already set up in my environment. That is why you're not getting any error. But if you see that, there will be an option for you that says fix this for me. Once you click on it, it will automatically create that parameter setup for you. Then you can select what is your target Redshift instance. It can be in your same account or it can be in a different account. Since my Redshift is in the same account, I'm going to use this. Choose. Another requirement for the Redshift is encryption. So when you're creating Redshift instance, it will already be encrypted, so it will not ask, it's not asking me right now, but it would similarly, it will showcase that there are some issues that you have to fix it, and it will give you an option to fix those. And if you don't have any custom encryption requirements, you can skip on this place, but be sure to add tags. As you know, tagging is always useful. If you keep add tags, you will be able to do the cost reports, cost usage reports. And that's it. And you can create on zero-ETL integration. It might take up to 10-15 minutes to settle that up, but once that is done, your integration is all ready. Since I have already created, it won't let me create another integration between same source and the target, so that's why I have to leave it. I'm going to cancel and go back. Okay. Now, in order to make this working and show exactly how the integration will work, I may have to do another trick. Just go back to RDS. So I'm in RDS only, but let's go back. Go to databases. I may have to update my security group because I won't have access to connect to this. So sorry for the last minute hack here, but I'm just going to say give access to my IP for now. Sorry? Oh, same IP, perfect. Oh, perfect. Sorry, I didn't have to change anything then. Okay, now let me then create my SQL interface. So what am I showing here is, uh, I already have created tables in RDS database, and I already had all that databases, all that tables integration already imported into Redshift. So that zero-ETL integration, which is supposed to create all the tables into Redshift, is already taken care of. So right now, I'm just going to show that if I have a table like this, I'm just going to show that there are no records in here right now. So if you see, there are 0 records. Right? I'm going to load that records. And I'm going to run the load S3 command, where we are actually, it is mimicking the scenario where you are adding, or there are multiple transactions coming together and updating the value table. So let's run this. Yeah.
Does it automatically, when you're using the zero-ETL integration, does it offload the data into an S3 bucket?
No. Here we are not doing this. Here I'm populating the data into RDS table from my S3 bucket.
Okay.
So this is like, let's say you are doing an online transaction. Your data get inserted. It will get inserted into an RDS database. So I'm doing that insert, but I'm doing bulk load. Okay, now let me go back to my RDS instance. Sorry, not my RDS instance, here my SQL instance. So if you go back and run the select query, let me copy it because I cannot see the screen from here, so it will be difficult for me. Okay, so how many records does it show? 202, right? All right. Now let's go back and to the RDS instance, Redshift instance. So you go here, go to Redshift. On the left, you will see the query editor. Click on the query editor. Here, I'm going to run this query just to showcase how much time it took to do the load. So you see this one? I think this is the latest transaction. Which one is the latest? I don't have it. We do star. In the meantime, when this is going to show the data when that last commit happened, what was modified, how many records got inserted, what was the start time, end time. You'll be able to get the metrics. Those metrics are available in CloudWatch for you to create a dashboard, but I just wanted to show it on the query too. Now let's go back to our table, demo table. And see the when. And if I run this SQL query, you will see that 202 records. Oh, I'm going to start here. you see two or two data there? So this is, I wanted to show actually, yeah, thank you. This is not my magic though, it's zero-ETL magic. So now we have got the data, it got replicated into Redshift, and you see that the data got replicated within few seconds. So now, once we have this, what are we going to do? The analyst analyst is there, and he wants to have, let's say, quarterly sales reports by event, or what are the top events in a quarter based on sales. So if we want to generate that report, if you look at the data that we have, I'm going to show it on a DBT so that we will know. I wish I had an option to do the duplicate here. Okay. So this is my project. Is it? Does it say NK at the bottom? Right? Yep. Okay. I'm gonna do develop cloud ID. So what do you think? If I have to generate a quarterly report for the sales based on event, what are we gonna do? What will be my step in the DBT project? Anybody has used DBT?
Create a model, select from that table, right?
Yeah. So I already have created model. So if you can see, there are the records. There is a select statement that we have created. And why do we need a transformation, right? If you look at the column names, it says price spread, sales ID, commission. If I'm the analyst and I've never seen this data before, I would not even know what that field means. So that's why we're saying that, oh, price ID as sales revenue. So then we are able to generate those reports that we're really looking for. And when you run the dbt run command on this one, it's going to generate this model onto Redshift database. Okay, the prerequisite for this is obviously, I'm assuming that you have already created a Redshift connection, so you are already done that. You have created your project, you have created your branch, committed the code, and then run the dbt run command. Let's see. I'm assuming this is a delay because of the internet and not because of dbt slow. Okay. So when I created the model, I created 2 staging tables, and then I created a sales report for quarterly and a sales report for event. So if I go back to my Redshift database on the browser, you'll see there's a dev schema created, and then I have a dbt ETL, as well as, sorry, there are 2. I see there are 2 tables created. One is the staging, and there are 2 views created. So if I run this, I'm able to get the data that I want. So first thing that I wanted to show was how easy it is to do zero-ETL integration between RDS and Redshift. So that is good. And then once you have all that data into Redshift, you can do the dbt transformation and have the data that you really need for analytics. And how many of you are using your data for doing real-time operational analytics? What do you do? What is your use case?
It's mostly to check the batch in and batch out events for us, and we supply that information also to the customers who bought our product. So that's our real use case, like transaction.
Okay. Anybody else? Has any fantastic story around real-time analysis? Okay. So I think with this, we are done with the presentation. One last thing I wanted to showcase, mention on the slide is, if you have any questions. Okay. So if you have any questions, we do have blog post for zero-ETL integration. Basically, this talks about how you can do zero-ETL integration. Same steps that I showcased here are available. There is another blog post coming up very soon, so in this particular blog post, we are only talking about Aurora and Redshift integration. But the new blog post that is coming in is talking about Aurora Redshift integration along with DBT. And there's also a real near-time analytics for zero-ETL future. And we are here if you have any more questions. Oh, a lot of questions. Go ahead.
Yeah, so zero ETL, right? Is that your extract and load? Because this is more of a replication. There is no transformation happening there, right? The transformation is happening after the fact with DBT.
Yeah.
So it's more of a extract and load,
Yeah.
and then you transform.
Yeah.
So second question.
It's extract and load. Just to clarify, it's a continuous replication, right? That's a key part. And after the data lands in Redshift, you can use things like Redshift materialized views or put DBT on top of it and do the transformation.
So when is the support coming for RDS Oracle?
RDS Oracle? Soon. I cannot commit to timelines on this stage. So, yes. So our goal is to make sure that Aurora is a starting point. However, we will be extending it to RDS databases, even third party. So our vision for zero-ETL is much broader, both AWS data sources as well as non-AWS data sources.
Do the tables that get created in the Redshift, can they be iceberg? Can they be in iceberg format?
Sorry, I didn't.
The tables that gets replicated into Redshift, can they be in iceberg format?
The tables that are replicating through zero-ETL, can they be in? Not yet. No.
So the connection is specified, right? So like it's complete schema, complete, or like can we specifically select like couple of objects in the schema?
Yes, we have a capability called table level, like filtering, data filtering. So you can pick and choose which subset you want to replicate into Redshift. Go ahead, I think. Yeah.
Should the two databases live on the same AWS account, or can they live in different accounts if we are going to perform this operation?
You mean the source or the target?
Source on one account and target in the other. Can that happen?
Yeah.
Yeah, they can. Yes.
On one of your slides, it was showing that autocopy from S3 coming soon, or
So autocopy from S3 to Redshift is in preview. It'll be GA soon, but yes, it is available. You can try it out. Yep.
thank you. I have two questions. What is the difference between DMS and zero-ETL? I mean, we are using DMS right now just to solve the same purpose, like our source table is into the RDS, and we are just loading into the Redshift. So why we need to switch it from that to here?
So the question is, what is the difference between DMS and zero-ETL? So if you are using DMS and if you are happy with the DMS, you should just continue to use it. The zero-ETL architecture, as I briefly mentioned, is designed much better performance, isolation, and resiliency. So it's a kind of, think of it as like a much more purpose-built integrations between these systems that is done at storage layer. So it's much better in terms of performance and efficiency.
Okay, my
Yep.
second question is, do you have kind of any automations kind of packages? My requirement is my source table are getting built, I mean, getting loaded every day with billions of rows, but I don't want to keep billions of rows in my source RDS table. I want to replicate everything, but just don't want to delete like month-old data prior to that from the RDS. But if I use the DMS, then I cannot perform all of these approach for the zero ETL. But I just want to keep a limited data in my source table, but everything in my Redshift.
Yeah.
my own packages or ETL tool, but do you have any kind of automation or any service?
Any way to retain the history, right?
Yes.
So this is our top feature request for zero ETL. So we are actively working on that. So with that, the capability that it will enable is even if you delete the data on your source system, we will be able to retain the history on Redshift.
Okay. Is it like kind of coming soon, like month, week, or year wise?
It's a top priority in the roadmap.
Okay.
I can talk to you offline. Yeah.
This is a real short one. You're talking about DMS versus the zero-ETL. Zero-ETL being more performant. How do they compare to each other cost-wise?
Same question.
So zero is good. Same question. So zero ETL does not have extra cost. So if you have your source and target,
I find DMS a little expensive. So
So that's the motivation to turn to zero ETL, right?
I'm assuming that, you know, the way DMS has a version control, like everything is a code, like you document your process as a code. I'm assuming that's not the case with zero ETL. It's mostly like you do things on UI.
so zero ETL has API.
So you can,
So you can create integration, modify integrations. You can do all of that through API.
I have a RDS system which is built long back ago. So can we use zero ETL in that system?
What's the question?
Older versions of RDS.
There are specific versions of RDS that are needed. I can talk to you offline. Yeah.
Neela put her LinkedIn QR code there at the end. So we're loving all the questions, and we definitely want to get to all you all. Give you guys dedicated time, so don't hesitate to reach out to Neela, and we can set up some additional conversations.
Thank you.
Appreciate you.